Good morning and welcome viewers. I am Mr. Anil Kumar Yadav, Assistant Professor at the Kashi Institute of Technology at MIRZAMURAD. Today we will learn about the topic of solution of differential equation, which is BTech second semester first year for biotechnology. Okay, that is very amazing topic and very confusing. Okay, so point to point we discuss about all. Okay, now we have here solution of differential equation. In that we have 3 points. First, variable separable, and second, homogeneous equation. Third one is the linear differential equation. These are all related to each other. If we have question, sometimes we implement first one and after that second one and then third one. Only little concepts we have in that. Okay, so all of you very clear about these ones. Firstly, if we apply variable separable, okay, for this point, for this heading, to get its solution in linear way or in any curve, we have first order. That differential equation order is first and degree is first. I think all of you be sure about order and degree in my lecture, in my first lecture, in which I will discuss about the order and degree. Okay, my dear student. So here now we take some examples or main concept from which we get the solution. Now see here. Suppose we have any differential equation in the form of dy upon dx, and it is defined in two functions, that is say capital F, and in which we have x and y as a variable. We may write that is first type of function fx, and another one is second type of function gx, right? Gy, gx and gy. Here we have differential equation dy by dx, which has degree 1. I think all of you well aware about the degree and order. If you have confusion, you must be watch my just a previous video in which I am discuss about the order and degree of any type of differential equation. Here we have d1 y1 dx. Okay, now for degree we here create like this, means power to the differential y dash y double dash, power to the differential equation. So we say this is first order and first degree differential equation. This is first order, and because if we, whenever we apply variable separable, must be there is order 1 and degree 1 of differential equation. Okay, so here we see that order 1 and degree 1. So we can apply variable separable. In homogeneous, same way we have order 1 and degree 1. Okay, these are very confusing points, so I am writing here all three together. Okay, because as point wise we will discuss about them, and it's a problem how we solve it in easy way. Okay, so in homogeneous there is one thing more. If you have any equation in first order, in first degree, any differential equation, it's a non-differential values or alphabets which must be same degree in numerator and denominator. Okay, at that time you will implement their homogeneous equation. Okay, my dear student. And lastly you have linear differential equation, or it has also order 1 degree 1. Now we here take the type or mathematical symbol of a variable separable method. Now mathematically that point we will represent in that manner. Okay, dy by dx fxy rh hx gy. So why we say this is variable separable? Because easily it can be write in dy and in dx term. Means all the y values of y are function of y you take with dy, you take with dy. So here you have function of y is what? Gy, and after that you have dx. Here after that you have what? Dx. So dx means dx is the operator and x is a function. Here x is a function of hx. Okay, and this is dx. So separately you can easily from cross multiplying you can separate function of y with dy and function of x with hx. Okay, so after that our point, our key point to proceed it. After that we integrate it in both sides. So on integrating we have in same manner function. So suppose that if you have in left side, okay, integration on after integration you get the log term, and in right side in left side in log term, in right side in log term. So your constant will be in log. If here is a log and here in another function, so never you put log as a constant. Okay, my dear student. So here we have what? Log gy, right? And suppose that that becomes to after on integration that becomes to capital H. Okay, and now we here add c. I'm talking about the c. What type of c we can here add? I'm saying just in a simple way. If you have in both sides log function, so there is a need to add constant as a log function. Otherwise it is wrong. Its solution will be wrong. So I think all of you understand how do you proceed in variable separable methods. Okay, in variable separable method, simply all of you keep in your mind all the function of y you kept with dy via cross multiply method. Okay, and all the function of x kept with dx. Okay, on via cross multiplication. Okay, so this is concept how we proceed to our any problem which is related to variable separable. Okay, now from few examples we be sure about this. So my dear student, come to see a fantastic and amazing example here. Now see here we have question dy dx. We have here y square upon. Okay, that is very funny or very little type question. We see here clearly. Here function of y is 1 plus y square and function of x is 1 plus x square. So my dear student, according to our theme, our key points, we via cross multiplication we carry function of y with dy and function of x with dx. So here in simple way we can write this. Here we have dx 1 plus x square. So easily we can write in that manner. Okay, via cross multiplication, that one goes in right side and this one goes in left side in denominator. Okay, on integration what we have? On integration, if all of you remember that this is a type of identity in integral calculus. Okay, that is identity of tan inverse. Okay, now here see that if you have tan inverse if you have 1 by x square a square dx, you may write this is as a tan inverse x upon a plus c. this is type of tan inverse. So its integration will be what? We have tan inverse y as a place of a. Here as a place, at the place of a we have 1 square. So here tan inverse upon 1, and here we have tan inverse x upon 1, because this is a type of a square plus x square in denominator to dx. Okay, now need to again we add the constant. So what kind of constant will be there? Okay, that is a very very important point and very necessary. Here both sides we have t function, trigonometric function. So you have no logarithmic function, only you have to some needful point for logarithmic function. Rather than all, you only add as a constant in any side as a c only. Okay, log, only in log, if you have both side log, you must be adding its constant in log only. Okay, so this is a little example on and amazing on a method of variable separable. So I think all of you very clear in the first type, variable separable. So my dear student, while some more interesting example, we proceed for homogeneous equation. Okay, so come to see homogeneous equation here. I think all of you sure. So I am proceeding for next point. Now, my dear student, second point, second heading is on homogeneous equation. So all of you already introduced about these points, I think, in your earlier class. Okay, and some are very clear and some are very confused among these ones. So if you have no any idea about its key point, all times all of you very confused. Okay, so for coming a homogeneous equation, we here see that order first, degree first. This is the same as previous one in variable separable also, order first, degree first. So what is contradiction between variable separable and homogeneous? Okay, here major difference, because both are both has same criteria, but it has something different. Means which equation is it has its degree which is not in a differential equation, its degree will be same. Okay, means a curve type equation or any linear equation you have. Now see, we much clear about be much clear about via example. See here we have example y dash y plus x upon x. Here we have example. Okay, this is a differential equation, and we can implement on that problem variable separable. Nothing, because we cannot separate easily here x with dx and y with dy. Firstly, all of you know, I think all of you know about the what means of y dash. Firstly, all of you write this, y dash is dy by dx. So if you easily separate x with dy, y with dy, so you can go via variable separable method. If you cannot, okay, did like this, so this means it is other type of a differential equation solution. So I am not able to separate this. Okay, so I am here applying second for point second and its key point. We have I have its key point here. I am here interested to check its numerator and denominator degree. So I am see here it is a linear equation, x and y both has degree 1 and denominator has also degree 1. So here we have as numerator and denominator both has degree 1. Okay, both has degree 1. Numerator, degree of denominator, degree of numerator, both has degree 1. So I am going for its solution via homogeneous equation process. So what we point follow, what we step follow in that problem. So first you let for homogeneous only. Okay, y equal to Vx. Means where is y, you must put at the place of y Vx. And secondly on its differentiation we get dy upon dx via by part rule, okay, via product rule, okay. First omit first, and on differentiation second we have 1, and second we have left second, omit second, on differentiation of first we have this. Means in a short way we can write this Vx dv upon dx. My dear student, this is we have last result of dy by dx, okay. So these 2 points are very important points via your solution will be a homogeneous process, okay. At a place of put y equal to Vx, at a place of dy by dx must be put, at a place of dy by dx must be put v equal to v plus x divided by dx. Means dy by dx, at the place of dy by dx we put v plus x dv upon dx. At a place of y must be put vx, okay. So on substituting this value in a given question, what we have now, we have here at a place of dv upon dx, okay, we have v plus x dv upon dx, okay. And here we have, this is not dash, this is 1, degree 1, I am showing here degree 1, okay. In right side we implement at a place of y equal to Vx, so what we have Vx plus x upon x, right. So on taking common x as a we taking x as a common, we have x d plus 1 upon x, cancel out xx, we have Vx dv by dx, okay, and we have v plus 1, okay. Now our equation is reduced to in a simple way. Now we have here in both sides v, so v is cancel out from both sides. Now we have dv upon dx plus equal to 1, plus 1 we say plus, that is 0 plus 1, and we write now 1. So this is what x dv upon dx. So if all of you be careful about that relation, you find out here very amazing result. This one is come to in variable separable concept. So okay, here we can carry variable of v with operator dv and variable of x with operator dx. So lastly we have now only 1 second more. If we have v equal to 1, here x dx. So my dear student, easily all of you see that on after integration you have get easily its result. What we have, v plus x square by 2. Now need to put here a constant c, and also need to put here, eliminate the v, because our initial equation in terms of y equal to v in y and x only. So it is our requirement to our final result only in initial variables, okay. So here we have at the place of v, what, y by x square by 2 plus c. So this is our final result, okay. This is our final result. So that is a way of question which is solving via homogeneous equation, okay. Now we have a last point, linear differential equation. I am writing these 3 one all together. That's only one reason. These all ones are related internally related to each other. So via together we can clear all concepts. Okay. So I am going for last one, linear differential equation. So my dear student, via example we can clear that linear differential equation. It has also a basic and its a frame or structure. If you identify its structure, you can easily get its relation. Okay, its a solution. If you identify its structure or relation, means you have to no trouble to getting its solution. Okay, its structure will be, you have a dy dx, dy upon dx, and you all of you see that it has degree 1 as order 1. Okay, and plus py equal to q. Okay, py equal to q. So this is a first type. It has also two type. It is the first type of linear differential equation. And what its solution will be? Firstly, we write IF, integrating factor, and because that is going in y, but with respect to x, so we here write IF into y. We see a coefficient of y here, so we write only IF into y. Okay, and after that very big integration, and IF into q, and our operation going in what? Because here with respect to x, so now here we write dx, and on adding c as a constant. So again, be sure about that structure. I have IF. What is IF? I am just proceed a few minutes here below. IF into y, because here our structure is going in y dash plus py equal to q time. So each solution carry that y, and after that I have IF into q dx plus c. Now here see what is IF. We say its full form, integrating factor, and that will be e power. Okay, all of you remember that, e power p dx, okay. E power p dx means you have the value of p which integrate power to e. Okay, means exponential. Some few interesting points. If you have suppose that e power log x square, this is my little bit question from all of you. If you have log e power log x square, then it's a simple value. What will, yes, if need to write all of you, it's the result. So what all of you write? Simply x square on taking anti-log. Okay, so all of you sure if you have any term e power log x, okay, e power log something, so that operator eliminated, only you have last result. Okay, that is also we have this very broad process. So certainly you kept that one in your mind for getting in very little time its result. Okay, so I think all of you we are very clear about all types of equation, okay, and its solution. We have left its question. In our next video we will clear about the that structure question. Okay, I think all of you very clear about all topic. So student, I am coming for in next video for more interesting points and question and headings. So thank to all to watching my this video, and please give me a like. Okay, give me a like. Thank you to all.